All right, let's try another one. So here we're going to integrate the function 3x squared divided by x cubed plus 1. All right, so let's look at this. And if we're going to use substitution rule, well, first of all, we want to think, is this one we can just do? And the answer is probably no. This is not one of our elementary forms that's immediately just recognizable from our table of ones we should know. And it's also, sometimes if there's division, we could do the division first, but that gets a little trickier when we have a denominator with more than one kind of term in it. So here we actually have two terms here. So there's probably not any algebra that we could immediately do to try to simplify this down. So we're kind of stuck. So that means substitution rule, most likely. All right, so first step, we want to choose u. We want to think about what we could possibly pick for u. And so to help with this, some of these things are not necessary, but they're helpful. When we have a kind of a complicated looking function like this, it helps to kind of break the function apart into its different pieces. So I might write this fraction just to kind of see where to possibly go. I might separate this into its different parts. So we have a fraction. Let me separate off the numerator. And I'm going to rewrite this as 1 over x cubed plus 1 times 3x squared. So these are definitely the same function. I've just kind of separated the fraction. So I have 1 over my denominator times 3x squared. Now when you separate it like this, and this can be a helpful thing to do. So if you're ever stuck, you're not sure how to choose u, sometimes it's helpful to break your function apart, to separate the different parts of your function. So if you're thinking, you're just not sure what to pick for u, try writing it, kind of factoring it out. So you have multiplication here. So we have 1 over x cubed plus 1 times 3x squared. And when you have these different pieces, you want to look at, well, what's the more complicated piece? So I have 3x squared here. I have 1 over x cubed plus 1 right here. I would say that's the more complicated piece. And so you're looking at this more complicated piece and you're trying to identify, well, what kind of basic form is this related to? So I would say this is the 1 over, that reciprocal form, 1 over something. We have 1 over something in the denominator. And so the strategy for when we have a fraction like this, and really it's a fraction with no visible exponent. So let's go back to our little strategies here. When we have a fraction, 1 over something, if there's no visible exponent, really it means that there's like a hidden 1. Then you let your u equal the terms in your denominator. If there was like a 2 down here, well then you would rewrite the fraction with negative exponents, and then you'd just let u equal the term in the parentheses. So this kind of exception case here is when we have no visible exponent on the term in the denominator. And that's precisely what we're seeing here. We have this fraction 1 over some stuff, and there's no visible exponent surrounding everything in the denominator here. So what we're going to do is we're going to let u equal those terms in the denominator, x cubed plus 1. All right, that's the hardest part. So once you make a choice for u, then you calculate du, so your hand is kind of forced. So the derivative of x cubed plus 1 is 3x squared, and then we multiply by dx. All right, so now we want to take these little pieces here, these ingredients, and we want to substitute them into our integral. And also why this is helpful to kind of break apart your function is then when you start substituting things in, you might see where the pieces go. So for instance, the 3x squared dx, it's a perfect match. And it doesn't always happen. We're kind of getting into it here, but we see that we have a perfect match and that this is going to become du. And then the x cubed plus 1 that we have down here, that's going to become u, precisely because that's how we chose u. So now that's step 2. Put the pieces in. So this fraction 1 over x cubed plus 1, well, we're going to change that x cubed plus 1 to u, so it's going to become the integral of 1 over u. And then this 3x squared dx, that's going to become du. And so we've substituted our pieces in, and now we have this much easier integral to do. This is one of our basic integrals. So notice that we went from this complicated integral involving x's to this simplified integral involving u's, one that we can actually do. So now in step 3, we actually do the integration. So the antiderivative of 1 over u is natural log absolute value u. Remember the absolute value. Then we have plus c. And then the very last step, we want to go back to x. So just fill in what you had. So it'll be x cubed plus 1. So natural log absolute value x cubed plus 1 plus c. And that's the 4th step. And we have our answer. So there's our antiderivative. And if you wanted to, you could differentiate using this general log rule to check your work. All right. Not too bad. Comes with practice. So you just need to try a whole bunch of these just to get that practice of how to pick u. So it's not always obvious right away. So the more problems you do, the more natural the choice is going to be here. All right, so we'll try some more.